Okay, so on the part of load matching for actuators, right? So actuator itself, or the motor itself, we've learned from chapter 2 to chapter 6 that it has a top speed characteristics. Okay, remember for a DC motor we have like a negative linear slope from a no load speed to a full load speed. And for AC motors, it has quite a different torque speed characteristics depending on the type of the AC motor side, whether it is synchronous or asynchronous. Okay, and the mechanical load itself has also a torque speed characteristics. Okay, so the motor torque speed characteristics refers to the drive capacity that is available from the motor itself. Okay, and which is needed to drive the load lah. Okay, so for the optimal operation of the system, we need to make sure that the torque speed characteristics from the actuator is properly matched with torque speed characteristic that is required by the load. Okay, so the matching of an actuator with a load should consider, firstly, the actuator or the motor itself should be able to start the load from rest. That means it should be able to accelerate the load from the stalling condition, or from the starting point, from rest into the working speed. Okay, or the optimal speed for the application to work. Okay, the actuator or the motor itself should be able to accelerate the load to the operating speed in a specified time. Okay, we need to make sure that it consistently can do that according to a speed profile or trajectory. The actuator or the motor itself also should be able to drive the load steadily at the specified operating speed. That means if there is an increase in speed, it should be able to get back to a steady state speed, or if there is a decrease in speed because of increase in load, for example, it should also get back into the steady state operating speed. Okay, so in this case, if we take a look at the torque speed characteristics of a load and actuator or the motor itself, we can see that the actuator or the motor torque speed characteristics must be, at the initial, must be larger than the load. Okay, it is important because we have to make sure that you can accelerate the load to the required operating speed. Okay, so if it is larger, it is able to start the load and accelerate to a higher speed. Okay, the operating speed or the stable steady state speed is where the point of intersection happens. Okay, so if we have the torque speed characteristics of the load, we can actually plot that together with the actuator torque speed characteristics, and the point of intersection is the speed and torque that are required for a steady state operation. Okay, so at this steady state operation, if the speed slightly increases beyond the steady state speed, the torque provided by the actuator becomes slightly smaller. Okay, then the system will decelerate back to the steady state speed. If the speed slightly decreases below the steady state speed, the torque provided by the actuator becomes slightly larger. Okay, so if it is becomes slightly larger, it will accelerate the system back to the steady state speed. Okay, so this is why it is important to have actuator characteristics as such, which has a larger initial torque in comparison to the load torque speed characteristics. Okay, alright, so the fourth consideration is that the consideration of friction. Okay, so friction actually plays a role in impending the force that actually causes acceleration. Okay, so we will always need to subtract it from the system force. Okay, or the force that driving the application. Okay, so the frictional force actually refers to a two type of friction, which is a static and kinetic friction. Okay, so the static and kinetic friction actually refers to the friction, which is the force that acts opposing the relative motion of surfaces, that happens when there is actually no movement. Okay, so it refers to both dry and rough surfaces, and it is high at these dry and rough surfaces, and it also can happen for smooth and wet surfaces, which is the friction at this point will be low. It's not like nothing, but you will have some kind of friction, but with a low magnitude. Okay, so if we take a look at the object that are in contact with the surface is in contact with another surface, we'll always have applied force in the direction of the movement, and you will have a friction force opposing the direction of the movement. You have gravitational force that are pulling the mass towards the earth, and the normal force, which is opposing the gravitational force. Okay, so the normal force is always perpendicular to the surface, and it is drawn like that for a free body diagram. Okay, so the force of static friction actually keeps the stationary object stationary. Okay, so it keeps the object still. So the coefficient of static friction is multiplied with the normal force. Okay, so in this case, the normal force times the coefficient of static friction is the static friction, the magnitude of static friction that actually happens opposing the forces that causes the movement. Okay, once the force of static friction is overcome, okay, the force of kinetic friction will slow down the moving object. Okay, so think of it like this: if you're trying to move something, okay, it is originally at rest. Okay, it's not moving. When you try to move something, it will kind of resist the movement because of the static friction of the object, so as inertia. And then when it moves, okay, as it moves, the surface slides over the other surface. Okay, and it has some kind of friction as well, because it will tend to slow down the moving object. It's not like when you start to move a bit and everything just goes smoothly. Okay, you always have usually if you move it on a rough surface, you always have to maintain the forces given to drive the movement. Okay, so as it moves, you will have coefficient of kinetic. You will have the kinetic friction, which is a multiplication of a normal force times the coefficient of kinetic friction. Okay, so that will give you the kinetic friction. So what static friction and kinetic friction does is basically static friction helps object to stay still, and the kinetic friction actually helps to slow down the movement. Okay, so when you want to abruptly stop, okay, you will either reduce the forces as well as take advantage of the kinetic friction forces. Okay, so the coefficient of kinetic friction and static friction is slightly different between each other, and obviously the coefficient of kinetic friction is always slightly smaller than the coefficient of static friction. And so this kind of material shows rubber on glass means rubber is in contact with glass, rubber on concrete, steel on steel, wood on wood, ice on ice, and synovial joints in humans. The synovial joints is joints like your knee. Okay, so as well as your shoulder, in which you have some kind of lubricants in it, but you still have a friction. Okay, the kinetic and static friction at each of the joints. Okay, all right. So this is the kind of activities that actually shows the importance of static and kinetic friction. Okay, so those who can take the advantage of both static and kinetic friction, okay, over time will actually see the benefit of it, and probably try not to have an accident because you forget that there is some kind of kinetic friction that you need to overcome, as well as a static friction that you need to overcome when you move. So this will this always apply in our daily activities. Okay, so typically when we try to determine the static friction, okay, you will have this typically the force detector or the force sensor that will that you use to drag a block of wood, that you know already the mass and everything, and you use the amount of forces that you actually control the amount of forces that you use to pull it, and you try to maintain the block with this constant forces, and try to maintain the block to move with a low velocity. Okay, so eventually we can have this kind of results, okay, the results. So you will linearly have the amount of forces used to overcome the static region, okay, and eventually you will have this kind of kinetic region when the block is already moved. Okay, so you line up the block with a motion detector. Okay, so you push the block gently toward the motion detector, so it comes to a stop approximately 1 foot away. So you can have from there the position versus time, and then you plot the velocity curve to determine the deceleration of the block, and then you can calculate here the force of kinetic friction, okay, and also determine the coefficient of kinetic friction. Okay, so from here, an example of it is that if you have an empty cart being rolled across the warehouse floor, if the cart was filled, the force of kinetic friction between cart and floor would, what happened? What happened to that? It would remain the same. Okay, all right. Why? Okay, the decrease, the kinetic friction is the friction that happens as you move. Okay, so the kinetic friction will depend on the amount of contact between the floor and the surface of the wheel. Alright, so it is the same thing, okay, whether you feel the because the amount of forces that you use to drag it, as well as the amount of weight that is actually you filled in, is basically will balance out each other, because that's how you need to keep it moving. So the contact forces between the normal forces between that will remain the same. So therefore eventually you will have the kinetic friction, okay, over time will always depends on the amount of contact between the surfaces. Okay, alright. So sand is often placed on icy road because the sand, well, basically increases the coefficient of friction between the tires of the car and the road, of course. Because when you put the sand on an icy road, you will make sure that your car does not slide. Okay, and the sliding actually happens because you have a low coefficient of friction, right? So that will actually conclude this lecture on power transmission and motorizing. I will go very closely to analyzing the type of drive in the next lecture. And hopefully I will see you on Friday to go through the tutorial of this chapter. Okay, so see you then.